This lesson is about properties of polygons. And a polygon is a shape that has all of its sides are straight line segments like this, and it's closed. It's not open anywhere. So if you see something like this, I say, is that a polygon? You say, well, no, because it's open right here. Or if you see something like this, is that a polygon? No, even though it's closed, it has a distinctly curved side on it. So these are examples of things that are not polygons. This polygon here, hopefully you know, is called a pentagon. It has 5 sides, and in this pentagon here, all 5 sides are the same length, and all 5 angles have the same measurement. And that means this pentagon here is called a regular polygon. Something else that we can use to describe this pentagon is since all of the vertices around this thing are pointing out, we can say that this is a regular convex polygon. Okay, so regular means all sides are congruent, all angles congruent, right? Convex means all angles point out. If that makes sense to you, it's just like it looks. I'm going to make another shape. So what I've done is I've taken the same exact shape I had and I've adjusted it so that all of these sides are not the same length. When all the sides are not the same length and all of the angles are not the same, you see now we have an acute angle here and an obtuse, so they're not the same. This is called an irregular convex polygon. Okay, so the only new word here is irregular. And that just means all the sides are not congruent, or all the angles are not congruent. That's all irregular means. Now there's one more word that we need to know about these. I'm going to bring the side in and cave it in like this. So I still have, if you count the sides, I still have 1, 2, 3, 4, 5 sides. So it's still a pentagon, but it's no longer regular because all the angles aren't the same. So it's irregular. It's also no longer convex because one of the angles is caved in here on the side. When I see this side caved in like this, I say that this is a concave polygon. So irregular concave polygon. And the word that you need to know out of this is concave, and it just means one or more angles. And you can say that they points in, or you could say one or more sides is caved in, if that makes sense to you. So whatever helps you remember it, but concave means caved in. Looks like when you got your learner's permit and hit it with your car. All right, so the next thing we're going to talk about is polygons in general. So here we have a irregular convex polygon. And if I just made a triangle, so let's say I just had a triangle here, you could tell me very quickly that these angles add up to 180 degrees, the interior angles. And I'll bet a lot of you, if I put a square, could tell me that these interior angles add up to 360 degrees. So the question is, if I have something with 3 sides, something with 4 sides, and now over here I have something with 5 sides. How can we figure out what all of these angles add up to? Is there some kind of pattern that we can follow to figure out the sum of the interior angles of any polygon? So it shouldn't matter how many sides it has if we can figure out this pattern. So give it a look for a second, see if you can come up with a pattern. Okay, what a lot of people will come up with is they say that, well, this is 180, so that doubled to 360, so when we go up by 1, we double it. Well, that's not not how it works, but it's a good try if that's what you came up with. It shows that you're thinking. When we look at a triangle, we know that the angles add up to 180 degrees because we've done this before, where you cut off all the angles, right? And then you line them up side by side, and they make something that looks like this. And you have this angle, this angle, and this angle adds up to 180. Well, if you cut all the sides off of this square, you spun all the angles around, they would look like this if you put them all together. 1, 2, 3, 4, and that would add up to 360. But if you took all of these angles and you started cutting them off, and you spun them around and tried to put them all together, they would make more than 360, and it would get really hard to tell what they are. But a nice, easy way to do it, a nice trick, is to break this shape up into shapes that you do know the sum of the interior angles for. So the way we're going to do that is to split it into triangles. So I'm going to take this shape and split it into a triangle. So now I've drawn this line across here, and this is called a diagonal. But I know this triangle right here is 180 degrees, right? I still don't know what this shape is because it has 4 sides, so who knows. But if I split it up into another triangle, well, now I know this triangle is 180 degrees, and this triangle is 180 degrees. So if something has 3 sides, I have 180 degrees. If something has 4 sides, there's a little part we left out, but hopefully you'll see it. If something has 4 sides, I have 180 degrees 2 times. If something has 5 sides, I have 180 degrees 3 times. So what do you think would happen if something had 6 sides? Hopefully you realize that it's 4 times 180 degrees. If something had 7 sides, it'd be 5 times 180 degrees. And there's a formula for this, no matter what the number of sides is. So in my triangle, or in my polygon here, let's suppose that I have n sides. Well, what number would I do times 180? So if I had 6, I used 4. If I had 7, I used 5. So if I have n, hopefully you can see that I would use n minus 2. So whatever n is, if n was 5, I would use 3 times 180, like this. If n was 6, I would use 4 times 180. If n was 100, I would use 98 times 180. So the Polygon interior angle sum theorem says that the sum of the interior angles of a polygon with n sides is equal to n minus 2 times 180. And that's a formula that you're going to need to have memorized. That's the Polygon interior angle sum theorem. All right, so now we have another polygon, and we're going to talk about something a little bit different. These are going to be called exterior angles, and we've done this before with triangles. If you remember, we had pictures like this where we had a triangle, and this was called the exterior angle. Well, we're going to talk about the exterior angles on this polygon, but instead of just having one on the outside and doing simple problems like that, we're going to have one on every angle, like this. So here's an exterior angle, here's an exterior angle, here's one, and here's one. Now, the good news about this is not going to be as complicated as you think. So if you look at my exterior angles I've created here, I have 1, 2, 3, 4, 5. Well, if I pulled those off, I started sticking them together, and this is me just adding up these angles to see what all of them stuck together would add up to. Hopefully you'll see that when I pull them all off of there one at a time, and I stick them all together, well, nice and pretty, they add up to 360 degrees. And that's going to be true no matter how many sides the polygon has. And if you don't believe that, we can go up to this triangle that I made here and do the same thing. Angles off of here, put them all together. This one's going to have to be turned around a little bit. They still, this was hand drawn, so don't get too excited. They still add up to 360 degrees. So any polygon, no matter how many sides it has, the sum of its exterior angles is 360 degrees, and that is called the polygon exterior angle sum theorem. And it says that the sum of the measures of the exterior angles of a polygon is 360 degrees. So every single one of them adds up to 360 degrees. So you might think to yourself, wow, that's really fancy, Mr. Lewis. So the answer to all those problems is always 360 degrees. And that is, as I'm sure you know, definitely not true. But we're going to take a look at how both of these can be used. So I'm going to start out with a pentagon here. Find the measure of each interior angle of regular pentagon A, B, C, D, E. And that just means that this is A, B, C, D, E. Well, it has 5 sides, and it's a problem about interior angles. So I know that this pentagon here, the sum of its interior angles is going to be n minus 2 times 180. Well, in this case, n equals 5 because it's a pentagon. So 5 minus 2 times 180 is 3 times 180, which is 540 degrees. And this is a common answer for this question. But you see it said find the measure of each interior angle. Well, that's easy enough. We take that, 540 degrees total, divided by 1, 2, 3, 4, 5 angles. And what do we get? 108 degrees. Pretty simple, right? So now I'm going to have polygon R, S, T, U, V. And I'm going to do the same exact problem. I'm going to find the measure of each interior angle. So I count the sides 1, 2, 3, 4, 5. And I do n minus 2 times 180. So 5 minus 2 times 180. 3 times 180, 540 degrees. And I go up here. I do 540 degrees divided by 5. But what's wrong with this? What's wrong? What mistake am I making here? I'm assuming that each one of these angles is the same, right? In this problem, I divided it by 5 because they were all the same. But this problem, you're not going to be able to do like this. In a problem like this, you're going to be given some extra information that you didn't have just now. But these 3 angles are 2x degrees, and these 2 angles are x degrees. So to do this, instead of doing 540 divided by 5, we need to do this. X plus 2x plus 2x plus 2x equals 540. Combine like terms. 8x equals 540. Divide by 8. X equals 67.5 degrees. Now, 67.5 is this angle. It's also this angle. But this angle is 2 times 67.5, which is 135, 135, 135. And if you add all that back together, these two add up to 135. So 135 plus 135 is 270. 270 plus another 270 is 540. So that's an example of the kind of problems you're going to be doing. We're going to do some more in class with exterior angles. So write down any questions you have and bring them with you tomorrow.